Okay, hello everyone, welcome to the OneClass channel. My name is Andrew, and I'm currently doing Stat and Math at University of Toronto. And today we'll be going over some commonly asked mathematical questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the link in the description below. Okay, so now let's start our session for today. Okay, all right. Let me just zoom in a bit. Okay. So our first question today is asking us what are the notations for the derivative of a function? Okay, so let's copy that down. So, oops. So what are the notations for the derivative of a function? All right. So let's consider the notation f as a function, and we can write y is equal to x squared plus 2, or we can also write fx is equal to x squared plus 2. We can say f is a function of the independent variable x, and y is a dependent variable. And so that is what functions are. And famous mathematics such as Euler, Leibniz, Lagrange, and Newton introduced different notations for the derivative. Okay, so let's say for the derivative, I'll just move this to the next page. Yep. So derivative notation. So first, we have what we call Leibniz notation. So Leibniz notation. Okay, so the Leibniz notations use the symbol dx and dy. So let's write that down, dx, dy. Okay, so they use the symbol dx and dy to represent infinitely small increments of x and y respectively, just as delta x and delta y represent the increments of x and y respectively. So, given an example, if we got fx is equal to 2x squared plus 3, then the following derivative can be expressed in Leibniz notation by d fx dx is equal to 4x. Or if we have y is equal to 2x squared plus 3, then we write dy dx is equal to 4x. Okay, so that's what we have for the Leibniz notation. Let's change the color. So then we have Lagrange notation. Lagrange notation. All right. So for Lagrange notation, the derivative of the function f is expressed as f oops, is expressed as this. Let me just zoom in a bit. Okay, so given a function, we use the one we have earlier. So fx is equal to 2x squared plus 3. Then the following derivative can be represented by f. The derivative of fx is equal to 4x. Okay. Okay, so that's what we got for Lagrange notation. Then we will have let me see. Oh, the Euler's notation. So we have Euler notation, which uses a differential operator denoted as D, the capital D. And so saying if we have a fx is equal to 2x squared plus 3, we will have d fx is equal to 4x as its derivative. Okay, and lastly we have the Newton notation. So for Newton notation for differentiation, we just need to place a dot over the dependent variable. So for example, if we let's use fx is equal to 2x squared plus 3, or let's say y is equal to 2x squared plus 3, then the derivative of it will be y with the extra point on the top is equal to 4x. Okay, so those are 4 different derivative notation that we have, and most of the time we use the first two, which are the Laplace and Lagrange. Yep, so I think that's all we got for this question. Let's leave a comment. Solution is correct. Well done.